Welcome. Good afternoon. Hello, hello, hello. I hope you are feeling all right. In this session, we're going to talk a little bit on not artificial intelligence, maybe augmented intelligence or actual intelligence sort of things for operations. But first of all, who am I to speak about this? My name is Fatih Nar. I'm a senior principal architect at Red Hat. Previously, I was at Google Cloud. Before that, I was at Verizon Wireless. Long time ago, Canonical, Ericsson, if you remember the company called Nortel. So I have been around for a while. I worked both as a software engineer, starting my career, and then turned into a systems engineer, and then solutions engineer and consultant in the field. I worked in the beautiful parts of this planet, from Azerbaijan down to Russia, down to the US, down to China, down to Middle East, delivery and good experiences, good people. In last 3.5 years at Red Hat, I have been heavily focusing on, probably you're familiar with the technology called Service Mesh, started with the Istio and then Envoy proxy journey, and then turned into full observability, observing the state of your systems and applications and stacks. And now we are experiencing that not necessarily everything we need, we already have it. There are some gaps in our knowledge. There are some gaps in the data that we have been collecting. And how those gaps can be fulfilled by means of using OpenTelemetry, OTel, as an add-on instrumented way of collecting data, as well as leveraging a extended Berkeley Packet Filter eBPF technology at kernel level without asking developers no more things. They're already suffering, so we better do our data harvesting ourselves without asking them anything else. So from that perspective, data harvesting, data consolidation, data cleanup, data association, data mesh, and then hopefully once you have a good yet ready-to-use data, turn that data into model training, model testing, QA testing, and then creating insights as the last step. So what we have been seeing, at least in my humble experience perspective, is because of the, I guess, the being popular thing, artificial intelligence, everybody's jumping, try to jump at least, from where they are into AI age, try to skip the data engineering part of it, which is the biggest mistake that you can do, because if you don't have the proper data to train and verify and QA, that's pretty much useless. What you're going to end up having is hallucination. So this session is mainly focusing on the experiences and the best practices that we have been seeing in the field for distributed applications at edge. So as edge could be various things, various meanings for different people, as in the sense of device edge could be where the consumer is utilizing your services as a service provider, or it could be a far edge where you deploy your services as the furthest point that to deliver those goods and services. And also it could be near edge and enterprise. For each step, there is a capability, capacity, and feature set that can be utilized for certain business purposes as well as technology purposes. From enterprise perspective, this is where the core data centers are. It could be the telecom service provider, private cloud, could be a Google Clouds, could be AWS's. And then when you move into near edge, could be a one step further, getting closer to the destination, could be enterprises that is using your private 5G services with the private 5G core deployments. Or from Google Clouds and AWS perspective, it could be GDC or it could be Outposts. When you go a little bit further with the far edge, could be your greengrass deployments or going to in-vehicle systems or transportation systems where you're predicting the part failure, or you can do the on-site diagnosis of the particular other consumers and services. So if I go back here, again, the challenges is mainly the latency between the consumer experience and the end serving system is one of the big hurdles that we need to worry about and address. Second thing is limited bandwidth. So we see the new project launches this morning, such as Edge Lake, if you notice those at the keynotes, and Edge AI. So there are two perspectives in that. So one perspective is at what Edge Lake is. Oh, I got to implement some sort of a data lake at the edge. That's one perspective. For me, it could be doable or not doable depending on what your real estate at the edge is. Because if your real estate at the edge is so minimal by means of rack space, by means of the power, by means of the weight and cooling, you may not necessarily implement data storage at edge. I'm sorry to say that, but that's the reality. The most you can do ephemeral storage. You will not have a data lake at edge. Say you will not have a data lake at edge at the, say, American Airlines Stadium. You may have it if you put more money and convince the people to give you more space and cooling and caring, security, you may, but that increases your operational expenditure. The other thing is as the limited bandwidth. Say, okay, I have the limit, I have the space, I have the money to spend, but yet the bandwidth from your on-premise to the central storage or central processing areas where you have the GPU cluster, if you have a limited bandwidth, not able to carry petabytes of data. Okay? Now, one of the big blooming businesses is esports, right? You have been following it. So having those esports, having not proper bandwidth up to cloud, not able to detect the behavior of the player, is he cheating, or this team is really onto something. So this bandwidth is another factor at the edge. So this is where it comes into, okay, maybe we should find it's kind of a middle ground. So we have some bandwidth, we have some real estate. Maybe we do store some data and maybe clean up some data at edge, but maybe some part of that cleanup data, processed data, ETL output, small ETL output, extract, transform, load, can be pushed to another processing facility as, say, in the sense of near edge or central cloud. And of course, from a business perspective, when you're doing such investments, say I'm going to have an edge infrastructure, edge application deployment, edge application placement, it has to be price performant. The total cost of ownership is not necessarily coming down to the megabits of data per second that you transfer, or it could be a number of CPU cores you can rent, but it's coming down to actually one basic thing. How much energy you are spending and you're paying for versus how much money you're getting back out of it. So it's coming back to one of the key initiatives in this, maybe in the last few years, is about the sustainability. So I don't want to talk too much about sustainability, but we have to associate the sustainability not in only the ecosystem, the green side of the house, but also sustainability of the business versus, now we have everybody talking AI, GPUs. Do you know how much power those GPUs are sucking out of the grid? It's amazing. If you look at the A100s to H100s, we are talking about now reaching to kilowatts of data per GPU almost now. Now we are talking, okay, I have a sustainable business, spending, cooling, as well as being environmental, and now we have AI. So we have to find the common ground to make sure applications we are distributing, the data they are generating, okay? The user experience out of that AI-driven applications is matching with the revenue return of investment versus total cost of ownership by means of spending energy, real estate rentals, and maintaining of it. Before my session, there was a beautiful session from a colleague from Cisco. And that was a great session. If you have missed it, go back and watch it, because it was so critical to understand two aspects of this observability. First of all, what is observability? In my humble view, observability is the key understanding of your systems, how they are behaving as expectation versus reality, and calculating the difference and trigger an action to close that gap. So as a summary, see where your system is, compare where it is supposed to be, and take an action to take it back to where it's supposed to be. If you're familiar with the Kubernetes, there's a construct called declaration, declarative state, right? What it means is I'm deploying an application with the expectation of the application state. If there is a derivation or drift from that state, Kubernetes takes action, right? If it is not behaving, responding, it kills that pod and respawn again to make sure the criteria are matching with the liveness prot or the health checks and so on and so forth. So to perform that as a platform, Kubernetes, our distro, OpenShift, performs the observability in different layers. Starting from infrastructure layer, could be network fabric, back in the Cisco case, great example, collecting the Cisco iOS logs and metrics. But we go beyond that on top of OS level. Kernel level, we collect all the hardware metrics as well as OS level metrics. On top, on platform level, at Kubernetes layer, we also collect metrics, events, and logs and traces. So MELT is not a melting, it's metrics, events, logs, traces. MELT stands for. So these are the critical data types. You may map events into alarms. In some vendors call it alarms, not necessarily events, but in general sense, you can see as an event happening, because event can be parsed and handled as an alarm as well. So collect all these 7 holy layers of OC, metrics, events, and logs and traces, pushing into a consolidated data warehouse from where you can do the ETL. I want to extract some part of the data and transform into some format and maybe associate with additional data enrichment with the other data lakes, and then train my algorithm. Train my algorithm could be in the sense of totally custom model training. Could be starting a pre-trained foundation model, just tuning it. Tuning it could be leveraging RAG, or tuning it literally using the additional data points to train the algorithm. We see all bottom up as well. So it could be a foundation model with the prompt engineering, or it could be a foundation model with the RAG, or go foundation model with the custom training, or fully scratch models. Depends on your use case, depends on your industry. We see all 3 types of variations. But from telecom perspective, where I'm coming from is most of the network operations is to be handled by custom trained models, small models, not the billion parameter models, but thousands of parameters models, small model, lightweight models. And there's another side of the telco, which is the CRM, support system, brick and mortar, that they start leveraging LLMs as well, because that's based on the CRM tickets, the support tickets, the marketing, the trend analysis, behavioral modeling. That is good to leverage LLMs, but when you look at the real-time metrics, that is this an alarm case? Because I have a case that model that is only focusing on MTU sizes and packet drops and latency. The 3 major characteristics, maybe a little bit more than that, but not many. So there are custom models that you can train and focus, and that model doesn't have to stay by itself in the wild. You can bundle that model with additional models, i.e. I'm hinting into multi-model execution, okay? So output of these multi-model execution can hint a total better output than a single LLM giving you generic output. But as I said, there are other side of the houses, CRM, ERP, the support system, where LLM perfectly fits by means of recommendations and analysis. All right. Everybody talks about observability, nobody talks about application performance testing. Why? Because our traditional way of doing testing is used to be, and still some part, buying a simulators, emulators from a third party. Say Ixia, this, and traffic loading. From network perspective, it is the protocols. I understand TCP, UDP, SCTP, and all that. But when you come into edge and edge applications, the performance, reliability, and user experience and redundancy of the applications can be tested by means of HTTP, HTTP2, gRPC sort of protocols, or SQL, and so on and so forth. Basic layer 7 protocols, right? And when you look at the evolution of the networks from 4G to 5G, 5G has introduced the concept of service-based architecture, SBA. If you look at inside the SBA architecture, there are pretty much 2 variations of protocol. One is HTTP2, all the SBAs are communicating with each other. There's one more, which is SCTP protocol to the AMF. If you eliminate, maybe just put that SCTP aside, rest of them are HTTP2-based interfaces, i.e., I don't have to buy expensive emulator or a hardware appliance to perform application performance testing. I can leverage HTTP-based performance loaders. Okay, say I have the application deployed. It could be a UPF, and there's a Mac application at the edge for CDN, or say license plate detectors. So I live in Dallas, Texas. We have a lot of highways, and we have an NTT, the Highway Association, doing the license plate detection now almost 15 years. So it is using a library called OpenALPR. It is literally running a small binary at the edge nearby the camera. There's a small cabinet at the entrance and exit points. It's doing the license plate detection, not streaming the whole goddamn image. It's just saying that, hey, this is the text that I extracted from the image of the license plate. So it goes in the central state, it can send you the bill at the end of the month. So what I'm telling you here is applications at the edge are real. Applications at the edge are heavily HTTP, HTTP2 based protocols for kind of east-west and north-south trafficking, okay? Out of which you can do predictive analysis, could be root cause analysis, could be continuous optimization and unified observability. All right. 2 steps back, what we talked about, there could be 2 ways of data collection. But one is based on assuming that your application or your software stack is generating the data for you to observe. Like I went and enabled the logs and the system crashed, usually a lot of things we hear in the past. And another one is, these KPIs already generated based on the schema that the vendor provided or based on the schema 3GP provided. That's one thing, i.e. data is there for you to harvest it. There's another reality, this goddamn application is not giving me anything useful, okay? And in that case, what can you do? So you either got to go to application developer, hey, I need these additional data points. Can you please create or add it into your logs or metrics? Good luck finding that developer and asking and delivering the new software version. That's not the reality. So the alternate is to go with using the external data generation points, such as eBPF at the kernel level, and you have to be really prescriptive about what you need out of that applications involvement at the kernel level, inter-process communication, memory, CPU, GPU utilization, and also you can create, actually, a service map without a code change, service map without introducing a bottleneck such as a sidecar concept with eBPF. And then you can bundle that with the additional data, could be OpenTelemetry, instrumented code, or the existing data points. So existing data points, additional data points, i.e. giving you richer data warehousing. All right, so our work in here, which I'm going to show you a demo in a bit, is mainly around, we have, as in the sense of a central cluster, which is our management cluster called ACM Hub, Advanced Cluster Manager. This is where our OSS, PSS, we don't necessarily do the PSS, but operation support systems is residing. It could be the ACM also hosting the other observability features, like in this case, and also the Ansible automation platform to deliver automated way of things. And from left to right, we have the single source of truth, the GitHub, where it accommodates all the configs and applications. We can trigger deployment through ACM Hub for application placement, and which is deployed in the bottom. It's called 5G clusters. We call them managed clusters. Those are the managed clusters, endpoint where applications deployed. And the following will be, okay, I want to know, I don't want to wait to rain. I want to know what would happen if it rains, okay? That's the main mentality shift. So before my application breaks, I want to know what would take it to break it and what happens if it breaks it without waiting real storm to hit. Then it comes into application performance testing. We have a plugin by means of webhooks to trigger that. In this particular case, our partner is DDoSify. So we trigger DDoSify application performance testing from multi-origin point into distributed applications. So say I have a CDN application. I have customers in here, San Francisco. I have an application deployed in Houston, but I have customers in Dallas. And I have also customers in somewhere in Palo Alto, right? So I can originate multi-origin traffic from multiple geographic locations into the system, where the application is deployed, and I can observe how they're behaving through this plugin approach. Once I run that test continuously, I can harvest the data, which is the line number 2, getting that data, and then feeding back to our management, which is line number 3, based on that application testing outputs, i.e. I created additional data points through that, and I ship it back to the management cluster to evaluate and take action. Say, in this case, which we did Mobile World Congress in Barcelona, we had the clusters in Barcelona and other clusters in Madrid. At the time Mobile World Congress was happening in Barcelona, there were a heavy boost of people inside the same location. So the CDN application couldn't properly handle the traffic. So we observed and we switched the traffic routing back to Madrid. The latency between Madrid and Barcelona is not that too much because the law of physics, it says that based on the distance, right? So it only added, say, 1.5 millisecond latency. But in that case, instead of failing with the 50x global error, we're still serving it, maybe a little bit less, but we are still serving the traffic. So as a summary from top to bottom, bottom to top, is performance testing, observe the outputs continuously, feed that outputs, data, observability, metrics, events, and logs traces into the decision-making logic of scaling your application or migrating your application or traffic rerouting is the main solution Blueprint is about. All right. If you go a little bit deeper, this is a Blueprint taken from one of the tier ones in Europe. What they have done is they integrated their hardware telemetry with the network fabric, and they mapped those observability points into action flows using Kafka message bus. So they converted all that data and ship it through a Kafka bus into their overall umbrella OSS system. The problem with this is a reactive approach. The reason I'm calling this reactive approach, it means something happened, an event triggered, I'm triggering that event into overall umbrella OSS. This is how usually telcos behave. Something happens and we take an action, and when something happens, we look at the logs, if the logs are there. And there's another approach called proactive approach. Instead of waiting something to happen, I continuously get the data and load the system with APT and get that data and to create points that where this system gonna be when the real storm is happening is called proactive approach. In that sense, you create insights. Insights means that thing hasn't happened yet, but it is really likely to happen. Let's go to the examples. I'm not sure if you can read this. If I jump quick. So top one is about the MTU. So in this case, what happened is the switching fabric, back to Cisco, the iOS version has changed, and when they were rolling out the iOS changes, the config model somehow didn't match the one that is really tuned into network. So MTU size got lowered. MTU size got lowered, caused more fragmentation in the network, and the system detected that, hey, it's predicted that network congestion will happen due to lower MTU case. Okay, so as a follow-up action, it triggered the workflow to revert back the configuration into original one, which is optimized one for that particular service provider. The second one is specific to 5G, which is the anomaly detection and the session management function, traffic pattern. So this was due to actually not able to scale the SMF. If you're familiar with the 5G, it's not easy to scale AMF and SMF because most of the, unfortunately, implementations are hard-coded between AMF select and SMF. It is supposed to go NRF, but it doesn't somehow. So SMF tied into certain eBPF based on traffic tracking area codes, tags. So in that case, the AI engine created the insight that the SMF was going to fail because there's a particular area where the concert was happening. The UPF couldn't scale out properly at the edge. The last one here is mainly from the infrastructure layer. How many of you recently bought a SSD or NVMe? One, two. When you're buying SSD NVMe, did you take a look at how many writes and reads it can do over its lifetime? It's limited. It's not infinite. So even it's a storage, it has its lifetime based on how much you utilize it by means of writing, by means of reading. So if it is the edge system delivering CDN or image recognition, those SSDs get heavy hit by means of writings. So if you had hit heavy writings, and not necessarily readings that cause a lot of trouble, but writing causes a lot of trouble, the lifetime of the storage, it goes dramatically down. So in this case, the system detected that the I/O performance, IOPS, is going not significant, but relative. There's a pattern that degrading over time together with the relation with the write operations. So the system triggered that, hey, you better get prepared replacing that particular SSD in this particular server, in this particular data center. So what it did, it created automatically a ServiceNow ticket to a vendor. Vendor shipped the SSD to the data center guy looked at, I didn't order this. But they were the tickets showing that, hey, there's a likely insights that this is going to map. So they did the maintenance automatically with this insights generated. So we see a lot of examples of this in the field as well, that the automatically replacing hardwares and as well as this rolling back the software versions or the enforcing the certain config models to apply. So this is the demo with our partner. That is go through this is the single node OpenShift at the edge. It's a single node, single worker node, a single system as a Kubernetes, which is accommodating the 5G at the edge. I want to do fast forward showing the DDoS-Fi agent, eBPF agent, harvesting the data for the data point that is not existing as of that day. So this is the cluster, which is a single node OpenShift at edge. The ACM hub cluster is showing the metrics, real-time metrics for the CPU, memory, storage, as well as it's going to scroll down and show you the GPU as well. If I stop this for a quick, I want to talk about this a little bit. So when you're doing a root cause analysis or going into deeper roots of who's failing what for north, south, or east, west, so these lines you see the color codes, green and yellow and red, is decoded based on the latency between those services. If there's a big latency between the back end and the front end, it's going to be showing as a red because the latency is above the threshold. And also all the service interactions, there is no open tracing, there is no Jaeger, there is no instrumentation. This is pure eBPF. So this partner did, with our consultation and guidance, implemented a data harvesting based on eBPF on the process list on each node and each namespace, and mapping those each processes to each other based on a custom-built hash key. Hash key is the TCP sequence ID. Hash key could be associating the payloads. So they able to create this map with 0 application changes. And you can go to the details of the tracing and see which process is actually calling which sub-process and what is the delay on it. And at the time, so when you collect that data, it could be metrics, events, and log traces. What this partner simply did is similar to what our friend at the Cisco showed, that they took that subset of that data they observed and they pass it to ChatGPT API, OpenAI API, and they get the response back and present here as this is a fail point, these are recommendations, and so on and so forth. Obviously, their work is not as impressive and extensive as our beautiful friend Cisco's work. That was really impressive. Please go watch it. It was really good data engineering process that they have implemented. But this was straightforward. Get the logs, metrics, traces, maybe just clean up the duplicates out of it, simple, and then ship it over the API, get the response back. Man, I'm talking too much. All right, that's my wife says. Not really. You know, that's interesting that I come and hear conference talk, and I'm at home, I'm a little bit silent, and I just get my brain calmed down, and she always says, "What's wrong with you?" I said, "I don't like talking, maybe." But you go conferences, that's a different thing. I talk with my colleagues and same frequency level people. So the reason I have this slide in here is, so everything we do as Red Hat is open source. So we develop the upstream, we take the upstream, we harden it, and we ship it as a product, right? But everything we do is upstream first, and then downstream, hardening it, QAing it, and branding it, and shipping as a product with the proper documentation, with the proper professional services. And all the people that we work in the field as a partner, as other customers, we encourage the same approach, open source approach, okay? And throughout this journey with DDoS-Fi, now it's called Antheon, they have been approached to be acquired, one of the big observability SaaS players, with a $0 offer. You know why? They threaten the startup they will clone their code if they don't accept their offer. Their offer was, back off from your venture capital contract, join me as an acquirer. So you're going to be an employee. So obviously this backfired because we are supporting as a partner. And the mindset is interesting. So open source, crowdsourcing, gathering beautiful minds and doing something, achieving something together, great. But when you see some interesting mindset people, but in the business field, I want to clone the code and make money out of it. Sure, you can do it. You can try. But you cannot mandate people to be your slave. That's against the human nature. So this is the end of my presentation. Any questions?
Can you explain a little bit the difference between what we saw in the diversified UI and what you can get with Service Mesh?
Okay, Service Mesh. Okay, Service Mesh, if it is in the sense of Istio, right, is based on a concept called sidecar. Sidecar means I'm standing here and I have a little toddler nearby telling me what to do as hearing from his or her mom. This is the sidecar. Can I live my life like this? No, because the fact that it's the bottleneck, it's the single point of failure. And also this fact that it has a overhead to me as a space, as a resource. So when you deploy a sidecar together with an application, that sidecar Istio container, it resources CPU and memory, and its capacity by means of data processing because it ties into CPU, right? And that is creating a single point of failure as well as choking. So what we saw in the field, it is useful to some sort of application if you have a proper scaling out that sidecar container resources. But another concern is when you attach another application to one main business application, you're creating another attack surface, okay? Which you don't maintain, you don't have the responsibility for. That's why the sidecar concept hasn't been so much popular in the telco domain. There are some telco applications using it by means of service discovery. So, okay, Service Mesh has 3 offerings. One is the service discovery. The other one is obviously observability metrics, because every traffic passing through that pod, you can collect the metrics. The third one is the traffic management. You can do the blue-green deployments and leveraging Istio ingress, egress gateways. So if you break those 3 into individual segments, I can able to do better observability with OpenTelemetry and eBPF. So I don't necessarily need Service Mesh. But if your point, I want to do blue-green deployments, able to differentiate one application version to another version and traffic steering between, you can have another ingress solution to perform that, right? And third one is service discovery. Service discovery is, we already have it in some certain fashion and way, such as cluster DNS in kube DNS approach. So to me, Service Mesh with Istio is a good solution to certain applications and certain scale and certain organizations, but necessarily big organization, network-intensive applications, or scalability-wise, it's effective. I hope that answers your question. So I have been warned 1 minute. One more question? If any questions? If not, please reach out. We have been working as Red Hat in eBPF domain and OpenTelemetry. Our OpenTelemetry operator reached GA. Will be growing a lot, and we'll be hiring as well. If you're interested part of joining us, feel free to reach out. I'll be glad to communicate with you.